Good evening everyone. So myself Dr. Sritam Supnarshi Sahu. I'm working as assistant professor in Department of Civil Engineering, SR University, Warangal. So in the last part of the video, we have discussed about the mixed design procedure based on IS 10262 2019, and I'll just make a quick review what we have learned in the first part, then followed by this second part of that one, where mostly we will discuss on the field corrections because that is more crucial in this part. So far what we have discussed, we have taken a case study. So based on that, we have assumed like M40 grade of concrete was there and PPC cement was being used, and given maximum size of aggregate is 20 mm, size of aggregate is being taken for the entire courses, and then it is given in the question exposure condition is RCC, severe RCC condition, workability is 75 millimeter, and all the chemical admixture is giving superplasticized and normal, followed by all the data is given for the any kind of your specific gravity data were given, water absorption data was given, and moisture content was nil in this particular cases. So that indicates whether you need to go for the field corrections or not. Okay, so which kind of field correction you need to do, so that will give you an indication from the moisture content. So in the further, when we'll proceed further, we'll also discuss on this particular field correction part. So in the first step, you have to do the target strength. As I said, f dash ck equals to fck plus 1.65 into s. S is a standard deviation. So as the given in the question M40, so fck value is 40. So corresponding standard deviation as well as the factor associated with the grade. So based on these two formula, whichever is higher, you consider that one is the target strength. Subsequently, in the step 2, we need to calculate the approximate air content. So air content, you have to refer to the table 3. So as in the question it is given maximum size of aggregate is 20 mm. So corresponding value you have to take for your air content value. Similarly, in the step 3, water selection of water cement ratio, you have to consider the these three figures are there. So in that, which curve you have to consider. So based on that, as your target strength is somewhere 48 megapascal, so you have to consider the curve 2. Why? Because curve 2 indicates the compressive strength value should be less than greater than 43 and should be less than 53. So as 48 is lying in between that, so we have to take curve 2. So 48, so somewhere around here, so we have to go proceed with this. So where it coincides with the curve, so corresponding value you have to consider for your free water to cement ratio. So in this particular case, we have taken water to cement ratio as 0.36. Similarly, we have to check like based on that water cement ratio, whatever you got, whether it is meeting with your exposure condition or not, that also need to be verified. For that reason, we have taken another reference, that is IS 1456 2000. So based on that, we have to consider the table 5. So it is there in the left hand side, you can see the exposure condition is being given and it is applicable for two cases. One is plain concrete, another is reinforced concrete. As in this case, we have given in the question the exposure condition is severe and this is applicable for RCC. So what are all the values are there? So for that severe condition and reinforced cement concrete, so you have all these data are there. So minimum cement content is 320 kg per meter cube, free water to cement ratio is 0.45 and minimum grade is M30 grade. So all these values are being given in the red. So based on that, we need to calculate whether whatever we have arrived so far, the water cement ratio you have calculated, whether it is correct based on the codal provision or not. So based on that, you have to calculate. So water cement ratio is 0.36 and what is the exposure condition? So maximum allowed is 0.45 and you have taken 0.36, then it is safe for that particular case because it is lesser than that of the data given in the based on the codal provision. Similarly, the minimum grade is for M30 and in this case we have designed for M40 grade, hence it is safe. Similarly, we have to consider the water content. So for the water content, what you need to do is you have to refer table 4. As I said, like all the data, whatever the nominal maximum size of aggregate is there, the corresponding value will be your water content value. And any value you are taking, say for example a 10 mm aggregate is there or 20 mm is there or even 30 mm maximum size of aggregate is there, the corresponding value is applicable for the workability of 50 mm. That similarly you have to see what is the question, what is given in your workability. In the question it is given 75 mm slump value. So that is why you have to take how much extra slump is required. So for that we have to take how much extra slump is there. So again you have a guideline is there. So the guideline says for every 25 mm extra slump you have to add the water content by 3%. So in this case we have a excess amount of water is required, that is 3% is required. So for that how much total water is required? So we arrived with that 186 plus excess is 3% we have to take into 186, because that is corresponding value of 20 mm aggregate 186. So you are getting 191.58 kg. But in this case, as superplasticizer also included in the mixed design, so that is why it need to have a reduction in the water, reduction is there in the case of superplasticizer. So as I said, if superplasticizer normal is being used, so you have to deduct 23% because the water retention is 23%. So the remaining is 77%. So you have to do 191.58 into 0.77. So whatever the value you are getting, that is the final water content value. Next step is your cement content. So cement content, water cement ratio you have already identified. So based on that you need to calculate the cement content. So once cement content is done, then you have to refer again the table 5, and the remaining part is the minimum cement content is there, that you need to check with the whatever you are getting from your code book and whatever the value you got from the calculation. So it has to be safe. So both the thing has to be safe, and based on the exposure condition as well as the data you got, if it is aligned with that one, that means your cement content is also satisfying based on the codal provisions. Then the next part we have seen is the aggregate volume. So aggregate, based on that we have to refer a table 5. So table 5, so maximum size of aggregate is 20 mm. So corresponding zone 2 value, because it is given in the question, is 0.62. But keep it in mind, it is applicable for the value of water cement ratio of 0.50. However, the water cement ratio whatever you have calculated so far is 0.36. That means there is a deficient amount of data is there. So deficient amount of aggregate will be 0.14. And here also your codal provision says for every 0.05 change in water to cement ratio, either you have to increase or decrease the aggregate by the rate of 0.01. So accordingly you have to calculate how much extra aggregate is required. Then whatever you have identified the base coarse aggregate volume with the extra volume, then you will get the final coarse aggregate by volume we are getting. Similarly, you can subtract from the one. If I consider the entire coarse aggregate and the fine aggregate as a one unit, then you have to subtract 1 minus the coarse aggregate, you will get the fine aggregate. So similarly, you are getting the fine aggregate is 0.352. So far we have discussed these things. And the next part we are going to discuss about the mix calculation from 1 meter cube. So far you have already identified all different mass of the cement you have calculated the mass of the water, you have calculated the all kind of your superplasticizer content, all the thing you have calculated. So now the thing is we need to do a final step that we call it as a mix calculation. So mix calculation always, as I said, we have to do it for 1 meter cube. Length, breadth and height 1 meter cube. How much concreting is required, how much ingredient of required, all the ingredients, cement is required, how much water is required, how much superplasticizer is required, all these things we need to calculate. So that is why always we need to represent in terms of 1 meter cube. So in that case, whatever the value you got it from the step 1 to 6, again you have to calculate based on the volume. So that is why first of all in the step 2 you have identified the air content and you got the air content of 1%. So I have written now, because I need to calculate everything by volume. So volume of entrapped air is, as you said, 1%. Again I have represented is in meter cube 0.01 meter cube. I have converted into meter cube. Similarly, the second is I have to calculate the volume of cement. So there is a formula is there to calculate the volume of cement, mass of cement, because the mass of cement already have identified in the case of step 4, divided by specific gravity of cement. The specific gravity data is given. As I said, all the data of specific gravity of cement, water, your fine aggregate, coarse aggregate, as well as your superplasticizer, it will be required. Without that, you cannot do the mix calculation. Okay. So then mass of cement divided by specific gravity of cement into 1 by 1000. So what you got? You got all your step 3, you got your cement content is 412 kg per meter cube divided by the specific gravity is 2.88 into 1 by 1000, because you need to calculate in the case of your meter cube. So you are getting 0.143 meter cube. So your cement calculation is done. 1 meter cube the cement volume of cement is required is 0.143 cubic meter. Similarly, we have to calculate all different ingredients, because one you have considered your air content, the second you have considered your cement, then the third one is your volume of water, because you know water specific gravity is 1. So mass of water you have already identified in the step 3 or step 4, because 148 kg, because once you calculate your water to cement ratio, after that the next step is your water content. So you have to calculate and make sure whenever you are calculating your water content, you have to deduct the superplasticizer if it is given in the question. If it is not given in the question, so you have to consider without subtracting, because superplasticizer sometimes we may not include whenever we are designing any kind of M30 grade or M40 grade of concrete. So that is why it is optional whether superplasticizer is there in the question or not there in the question. You have to check. Once if it is not there, then you need not deduct any kind of your water reduction, should not be deduct whatever the value you are getting. So that value will be your water content value. So in this case, our mass of water is 148 kg per meter cube. So into specific gravity of water, everybody knows it is 1. So into 1 by 1000. So I am getting your water content, volume of water will be 0.148 meter cube. Now I have identified air, I have identified the cement content, now I have identified the water. So what else are left? So for me, superplasticizer is left, or the chemical admixture is left. So as I said earlier, so superplasticizer, whenever you are going to use that one, or the dosage is basically 1% by weight of cement, and this data is applicable whenever you are using a normal concrete. Make sure it should be a normal concrete, then the dosage of superplasticizer normal will be 1% by weight of cement. But in case of your, if you are using superplasticizer, and that too if you are using for your PCE based, that means it is applicable for a high strength concrete design. So in that case, instead of 1% by weight of the cement, you have to take 0.5% by weight of cement. So that is why some slight changes are there when you are designing for a normal concrete as well as when you are designing for a high strength concrete. So there will be some kind of dosages will be slightly different. So now we need, as we are designing for a M40 grade of concrete, so that means you have to use 1% by weight of cement. So earlier you have already identified how much volume of cement, how much cement content is there. So earlier you got the mass of cement is 412 kg per meter cube, and as I said, your superplasticizer dosage will be 1% by weight of the cement. So cement will be 412 kg per meter cube into your 1%, that means 4.12 kg you have to use. The mass of the superplasticizer is 4.12 kg. So now based on the same formula, mass of the superplasticizer divided by specific gravity into 1 by 1000, I will calculate the volume of superplasticizer, because all these ingredients whatever I am using for my mixed design, I need to convert into volume. So that's why 412 kg divided by the specific gravity of superplasticizer, that is 1.145 into 1 by 1000, so that I am getting 0.00359. So I just make sure, so it is 0.0036. for the nearly I am taking the higher value. So my volume of the chemical admixture is 0.0036. So after that, your next step will be whatever the step you have done or whatever the volume you have calculated, because everything, all the ingredient we consider as a 1 meter cube, right? So whatever you have calculated, you have calculated the first one is your air content, second one you have calculated your cement content, then your water content, then finally you have calculated the volume of your superplasticizer. If all these ingredient I sum and I subtract from 1, so what I will get? I will get the aggregate content, total aggregate. It will be a summation of fine aggregate and coarse aggregate. So that is why what I need to do is I need to subtract from 1, because all combination of all these ingredients, cement, fine aggregate, coarse aggregate, water as well as the air, if all these things are there, it is a 1. If I subtract all from whatever the data I got, if from a 1 if I subtract, so whatever the remaining value is there, that means the aggregate value, if I subtract from 1, I will get my aggregate content. So that is why, so aggregate content, what you need to do is 1 minus volume, all the volume of whatever you have got recently. That means you got the volume of your air content 0.01 meter cube, you got your cement content 0.143 meter cube, you got your water content 0.148 meter cube, and your volume of your superplasticizer dosage, that is 0.0036 meter cube. So all these things if I subtract from 1, I am getting the value 0.695 meter cube. That means volume of all total aggregate I am getting 0.695 cubic meter. So this value I am representing a symbol, that is my G. So what is G? So we will use, because once we got the value of G, volume of all the aggregate in G, then I need to calculate how much mass of aggregate I need to use. Both mass of fine aggregate as well as mass of coarse aggregate I need to use. So that is why I need to calculate the mass of coarse aggregate as well as mass of fine aggregate. So for that case, there is a formula is there, G into volume of coarse aggregate, because already in the last step you have already identified volume of coarse aggregate as well as the volume of fine aggregate, into specific gravity of coarse aggregate. All the data are given, specific gravity of coarse aggregate and fine aggregate is given into 1000, because we need to find out the mass of the both coarse aggregate as well as fine aggregate. So how we will calculate the coarse aggregate? So G value already you have identified 0.695, same value you have to write, and the volume of coarse aggregate, if you remember that volume of coarse aggregate in the last slide you have already identified. So volume of coarse aggregate is after summation of the extra aggregate plus the value whatever you got from the table 5, if you sum it, you are getting the coarse aggregate is 0.648, and you subtract from 1, so you are getting the fine aggregate, that is 0.352. These two data you have to consider when you are calculating the volume of your coarse aggregate as well as fine aggregate. So G value is already given 0.695. The value I got it, the volume of all aggregate into volume of coarse aggregate. As I said, the step 5 at the end, I calculate the volume of coarse aggregate and fine aggregate. So corresponding value I just took it. So coarse aggregate value is here 0.648, and specific gravity data is given. It is both are in SSD condition. So 2.74 into 1000, because I need to calculate in the mass of the coarse aggregate. So I am getting my mass is 1233.98, that means 1234 kg. I am getting the mass of the coarse aggregate. Similarly, I need to calculate the mass of fine aggregate. So mass of fine aggregate, the same formula, G into volume of fine aggregate into specific gravity of fine aggregate into 1000. So G value is none other than 0.695 into, same step 5 I got the coarse aggregate as well as the volume of fine aggregate. So I have taken the fine aggregate volume 0.352 into specific gravity is 2.65 into 1000. So I am getting nearly about 648 kg. So both coarse aggregate as well as fine aggregate I have identified from this mixed design. Then whatever you summarize from this, that will be your first trial. So that means if I summarize all these things, so what I got from my mixed design as of now, from the first trial mix, I need to use my cement is 412 kg per meter cube, water is 148 kg per meter cube, both fine aggregate and coarse aggregate is in SSD condition, that means saturated surface dry condition. So fine aggregate is 648 kg per meter cube, coarse aggregate is 1234 kg per meter cube, and chemical admixture is 4.12 kg per meter cube, and your water to cement ratio I have identified as 0.36. So these all data from the trial mix you got. But that is not the final one, because as I said, we need to calculate or we need to identify whether there is requirement of any kind of field corrections or not. So in order to go for that, what we need to do is we need to find out whether there is a requirement of adjustment in the water is required or not, and which case you need to consider whether it is a dry condition or a wet condition. How you are going to check? So for that reason, you have to again go back to your question. So question you can easily identify whether it is a clear case of dry condition or wet condition. So how you are going to identify? You see here the moisture content of aggregate is given. So moisture content of aggregate for both coarse aggregate and fine aggregate is nil. That means no moisture has ingressed into the aggregate, rather the fine aggregate or coarse aggregate. If no moisture has ingressed or no moisture has come inside this aggregate part, that means it is a clear indication of dry. So you have to consider the dry condition. But conversely, if the moisture content data is given, so that means it is a clear condition of your, that means in that case you may get a question like further some data is required, that is free moisture content. So free moisture content you have to subtract the water absorption value, then only you will get the how much the moisture content is given. Okay, so accordingly you have to identify whether you need to go for a wet correction or whether you need to go for a dry correction. In this particular case, what we have seen as the moisture content of the aggregate is nil for both the cases, both fine aggregate and coarse aggregate. So hence it is the clear indication that we need to go for a dry condition. So if we need to go for a dry condition, so what changes we need to do? So for that dry condition, there is a formula is there, mass of fine aggregate in SSD condition, because all whatever we have identified or calculated, that is based on the SSD condition. So we need to calculate the mass of fine aggregate in SSD divided by 1 plus water absorption divided by 100. So that is the clear condition of the fine aggregate we need to calculate in the dry state. So what is the value? So as you saw already, you have identified the fine aggregate mass. You can see here fine aggregate mass you got 648 kg per meter cube. So 648 divided by 1 plus water absorption value is for fine aggregate is 1%, so 1 by 100. So you are getting 641.58, so nearly 642 kg per meter cube. It is in the dry state. But you keep it in mind, whenever there is no moisture is there, your fine aggregate will have a value of 642 kg per meter cube. But how much you have identified if it is not a dry condition? So you got SSD condition, that means surface there is some kind of water content is there. So you see, whenever SSD condition is there, your water content value is slightly higher. That means your fine aggregate is 648 kg per meter cube. However, in the dry state, the same content you are calculating and you are getting 642 kg per meter cube. Similarly, we have to calculate for the coarse aggregate part. So the same value, like mass of the coarse aggregate in SSD condition divided by 1 plus water absorption divided by 100. So the same way, the mass of coarse aggregate in SSD, you can see here 1234 kg per meter cube. So that means 1234 divided by 1 plus your water absorption for coarse aggregate is 0.5%, so 0.5 divided by 100. So you are getting 1227.86 kg per meter cube. That means 1228 kg per meter cube. If you again check if it is a dry condition, okay, and you check with the SSD condition, you see there is a clear indication that SSD has a slight higher water absorption. That means water has already been absorbed into the aggregate, both the coarse aggregate and fine aggregate. So how much you see the coarse aggregate in SSD condition was 1234 kg per meter cube, but when we go for a correction and for a particularly dry correction, the same coarse aggregate dry condition is showing 1228 kg per meter cube. That means how much we need to calculate, how much excess or extra water is required based on the fine aggregate and coarse aggregate addition. So for the coarse aggregate, how much extra water is required? So how you are going to calculate? Because already you have calculated the both mass of the coarse aggregate and fine aggregate in SSD condition. Similarly, mass of the both coarse aggregate and fine aggregate in the dry condition also you have identified. So what you need to do is, if you need to calculate the how much excess water is required, so in that case the SSD minus the dry condition for both the cases, both the fine aggregate and coarse aggregate, if you do, you can get to know how much excess water is required. Okay, so how you are going to calculate? You see, this is the clear condition of dry condition. So you are getting for the case of fine aggregate it is 642. However, in the case of your SSD condition, your fine aggregate is 648. So that means what you need to do for the correction in case of your how much excess water is required for the fine aggregate is 648 minus 642. So that means you are getting 6 kgs of per meter cube fine aggregate excess water is required. Similarly, for the case of coarse aggregate, you see here the coarse aggregate dye condition it is 1228 kg per meter cube. However, in the SSD condition, the clear you are getting for the trial mix one is 1234 kg per meter cube. That means what you are going to do is, you have to subtract from SSD condition minus dry condition, you can get how much excess water is required for the coarse aggregate. That means 1234 minus 1228 kg per meter cube. That means you are getting 6 kg per meter cube of water is required for your coarse aggregate. Similarly, 6 kg per meter cube of water is required for your fine aggregate. That means all total 6 kg plus 6 kg, that means 12 kg additional water is required for your any kind of field corrections you are doing. So that means the total water content here right now is, so how much water content you derived after subtracting the superplasticized dosage. So plus here 6 kg is water is additional required for the case of coarse aggregate. additional 6 kg is required for the fine aggregate. That means 6 plus 6, 12 kg is required. This 12 kg will be added to the 148. What is the water absorption, what is the water content value you have identified in the previous mixed design procedure? So that you have to add with the 12 kg. That means all total 160 kg per meter cube water is finally required to do estimate the water content. So that means all you have done the mixed design trial 1, then after that how much correction is required, that also you have identified. So all total in a summary sheet you can also write, so how much mixed proportion after adjustment of dry aggregates, because we never assume, it is the question is given there is no moisture content, that means it is a clear indication of dry condition. So dry condition, so all these are the field corrections. That means how much cement is required? Cement is required for 12 kg per meter cube. Water to be added right now, because you have added both additional water for the case of after the correction is being done. So both 6 kg and 6 kg, that means 12 kg is being added. So the final water content is right now modified as 160 kg per meter cube. And similarly, fine aggregate and dry condition, it is 642 kg per meter cube, and coarse aggregate dry is 1228 kg per meter cube, and the chemical admixture is 4.12 kg per meter cube, and the last one is free water to cement ratio is 0.36. That means what you understood from this is whenever you do a dry mix or whenever you do a field corrections, that means you have added some additional water. You assume or you can identify earlier case when you go for the trial 1 case, you see the water was 148 kg per meter cube, but however how much water finally it is required, it is 160 kg per meter cube in order to get a good workability with a clear indication of your fine aggregate, how much is required, coarse aggregate is required, how much will be a cement is required, and how much will be your chemical admixture is required. Okay, so now I'll just make it summarize what are all the steps you need to follow in order to go for your mixed design for your all kind of, say we have taken here a clear example of M40 grade of concrete. So the first step is you have to calculate what is the mean target strength. For that you have two formulas are there. One is F-CK equals to FCK plus 1.65 into S, or F-CK equals to FCK plus X. So out of these two, whichever is higher, you consider that as your target strength. Then the second is you need to calculate the air content. So air content, you have to refer table 3. So in that case, how much will be a maximum size of aggregate? The corresponding value will be your air content value. Then the selection of water to cement ratio. So for that, you have to check with the curve, figure 1. So if your target mean strength from the step 1, whatever the value you are getting, you consider that is your y-axis value. So from the y-axis value, so based on that, say for example, if it is 33 to 43 megapascal strength is there, so you consider the table figure, your graph number 1. If you need to take a curve number 2, if it is greater than 43 and less than 53, you have to take the curve 2. If the target strength is greater than 53, so you have to consider the curve number 3. So corresponding, when it touches to the x-axis, the corresponding value will be your free water to cement ratio. So once you identify the water to cement ratio, you need to go for the water content value. So before that, once the water to cement ratio is being confirmed, then you need to check whether it is meeting with your criteria or not, because it has to also verify with your exposure condition, your environmental condition. So for that, you need to cross check with the IS 456-2000 table number 5. So based on that, whether your maximum cement content is satisfying or not, whether your whatever the free water to cement ratio you have taken, that is satisfying or not, and what is the grade of concrete you are designing, whether it is satisfying or not. Once it is satisfying, then you move on to the next phase, that is the selection of water content. So in that case, if selection of water content, you have to refer table number 4. In that, say you have to take the maximum size of aggregate, what is the corresponding value you are getting, that value will be applicable to a slump value of 50 mm. And in that case, we have a codal provision is there for excess every 25 mm slump, you have to add 3% of water content. So accordingly, you have to calculate the water content. Again, you have to take your, say for example, superplasticizer is there in the question or not. If it is there in the question, so if you are designing for say PCE normal, then you have to subtract 23%. That means 0.77 you have to multiply, because PCE normal will be your water retention is only 23%. However, if you are designing for a high strength concrete, in that case you have a more water retention. That means you can take 30%. That means you have to multiply by 0.70. So accordingly, you have to calculate the final water content. Once final water content is done, then you have to calculate the cement content. Then after cement content, you have to calculate the aggregate content. Aggregate content in the sense you have to check with the based on the codal provision how much excess aggregate is required. For that, you have to refer the table number 5. And once aggregate is being done, then after that you proceed with the how much excess aggregate is required. And here also, like your workability, you have a codal provision. So every change of water to cement ratio 0.05, you have to add the aggregate content by 0.01. So accordingly, you have to calculate the aggregate content. Once aggregate content is done, then all the value whatever you got it from table from step 1 to step 6, you have to convert into 1 meter cube. So air content is how much, your aggregate content is how much, your water content is how much, your cement content is how much, your superplasticizer content is how much. So all this you have to convert into per meter cube. So once you subtract from the 1 meter cube at the total all this ingredient, the value known to you, so you will get a total volume of aggregate you can identify, and that you represent at the value G. So after you calculate the G, you have to calculate the mass of both the fine aggregate and coarse aggregate. So that is a simple formula, mass of any kind of fine aggregate or coarse aggregate. So first is G into volume of coarse aggregate, that you already identified in the step 5, into specific gravity into 1000. So you will get mass of fine aggregate as well as coarse aggregate. Then the next part is your field correction. So field corrections, you need to check whether in the question it is moisture content is given or not. If moisture content is nil, that means it is a clear indication of a dry condition. So dry condition, so you have to have you have to check what is the mass of the coarse aggregate or mass of the fine aggregate divided by 1 plus water absorption by 100. So accordingly, you can get both fine aggregate and coarse aggregate. So of that value will be your dry condition. So then after that, you need to calculate how much your excess water is required. So that means the SSD minus your dry condition will give you the water content for both fine aggregate and coarse aggregate. So all you club it. So final water content will be added up this aggregate, how much excess water is required for both the fine aggregate and the coarse aggregate dry conditions. So in this case, we have added and we came to know this is 12 kg per meter cube water is required. Okay. So this is all about the today's mixed design, and in the next video we'll like to try. So far we have seen the design for M40 grade, but what changes will be done if we design for M40 to M100 grade? That means we need to classify a high strength concrete design. What design philosophy we need to maintain, what design criteria we need to follow, that will be we can see in the next video. I am going to make it for that, so that you can also get to know about how your changes of the mixed design philosophy for a normal conventional concrete, as similarly how a mixed design will change if your design change from M40 to M100 grade of concrete. What changes you are going to see, that we are going to see in the next upcoming video. Okay, till then, bye bye, good night, thank you.